Today we are going to talk about Newton's second law, which states that acceleration is directly proportional to net force, while it is inversely proportional to mass. This means that acceleration will go up when net force goes up and mass stays constant, while acceleration will go down when mass goes up and net force stays constant.
We learned that mass is a measure of inertia and is represented in kilograms. It stays the same. No matter how fast you fall or how far you go, you will continue to have the same mass because inertia will be the same. Weight is a measure of force and is represented in newtons. Weight changes depending on the gravity, which on Earth is 10 meters per second squared. Weight changes because gravity changes depending on where you are and what your mass is.
Free fall is the state when the only force acting on an object while falling is gravity. The acceleration on a free-falling object is gravity. The equations used to figure out how fast and how far objects in free fall are 2d equals 1/2 gt squared and v equals gt, which in this case acceleration is equal to gravity.
Projectiles are objects that move through the air or through space under the influence of gravity alone. Projectiles have two velocities that act on them, which are the vertical velocity, which changes at 10 meters per second squared, and horizontal velocity, which stays constant. Remember that the two velocities are independent of each other.
Terminal velocity is the state when the force of the air equals force of the weight on an object falling. The object during terminal velocity will no longer accelerate or change its velocity after that point.
To increase air resistance, you can increase the velocity of an object or increase the surface area of the object. For example, when you are skydiving and you open your arms, the action increases surface area, and therefore your air resistance will be greater. Because the air resistance is greater due to surface area, the velocity will decrease because it is not needed to achieve terminal velocity.